the IO module for the IO card, it's basically, this is being differentiated actually with the number of pins. Okay, like Arduino Uno is there, Arduino Nano, like Mini, Leonardo, everything. Similar to that, that's how we differentiate the IO module for the IO card. So why I'm taking Arduino every time? It's like it's the most simplest thing or the most common thing every engineer will be having an idea of. So that is why I'm taking that. So this is how we differentiate IO modules for the IO card, basically depending upon the number of pins. So again, coming up here, we can see that the label is like the QX40. Okay, so in American standards or in the Asian standard, in the European standards, we use either I for the for the input, and in Asian countries we use X as for the input. And when coming to the output, in Asian countries we use Y as the output, and in European standards and the American standards we use Q or O as the output. Okay, so from that also we are able to recognize that like which country of origin is from the actual PLC system. So that is also an information that I have to get. Now, what is inside a PLC? Okay, so this is the most other factor that you have to consider. Like when I told about the evolution, everyone must be thinking that why a relay system was compromised to a control system. Okay, and why pneumatic systems? And still, pneumatic systems are widely, commonly used nowadays also. Okay, and why pneumatic systems was compromised and we move on with the relay system. So for that, the story begins with like the pneumatic system, we need to actually control the valve. How we are controlling the valve. Again, we are using a pneumatic system, or again, we are using a mechanical system, or we will be assigning a particular person in order to control the valve. Okay, exactly like something similar to Charlie Chaplin's film, like the Modern Life or something. In that, he used to supervise, he used to work inside a factory unit, and he used to control a particular valve. Okay, so that is what a pneumatic system, those days, how it works. And some of these valve controlling was changed to the relay system. Not the entire pneumatic system, but some of the major parts of the controlling of the pneumatic system was changed to relay system. So relay system, as you all know, we will be having like commonly a relay will be having an NC common and an NO and the actuating side. Okay, this is the actuating and this is the output side. So NC is a normally closed and the NO is a normally open. So when we are connecting, if we are connecting in the common with the 230 volts, and relay is actually always closed. Okay. So if you are connecting a bulb here, it will be glowing up always. If you are providing a signal from anything like an Arduino, or if it is a PLC system. Okay. And that is what I normally close. And we need to benefit. Now the logic is like when this light is glowing in, and when a particular signal is actuated, this normally closed changes to normally open. And again, we will be having a light here that will be glowing once this is actuated. Okay, that is how a relay system actually works. So again, that is what relay system is. So again, we can see that we are having a large number of relay systems here. So the main difficulty in a relay system is troubleshooting. If a relay is actuating another relay, that relay will be actuating multiple relays. So any of these relays will be having any kind of issue, we will have to just take on the wire. We have to check the mechanical parts because in those days we weren't having the solid state devices or the solid state based relay system. So we have to check individual wires. We have to check the relay mechanical parts. So that was a hectic job actually. So then only we like that is why I just mentioned that in the late 1950s we were having the most vital invention, which was the transistor. So the combination of transistors. PLC is a combination of transistors actually. So that transistor is working similar to or like exactly like a relay system. Okay, so why can't we use a relay system inside a PLC? Because relays, if we need to activate this, we need a controlling system, and that will be nowadays we can call it as we have a microcontroller, we can have a microprocessor. Okay, so if you are having a microcontroller here, we can have a transistor here also. Okay, and that too instead of these number of pin outs. Instead of this, we can have a 3-pin transistor, and we can control the emitter and the controller by activating the D. Okay, so simple as that, that is being done. So this logic has to be understood by, this logic should be understood before we have to move on or before we talk about the logical part inside a PLC system. So in a relay, we do have the 5 volts and the ground, and that is the input side or the actuating side. Okay. And here we have the sensing side or the where we connect the sensors. So the normally closed and the normally open, and the common part. The common part is where we connect the 230 volts, or sometimes we used to connect the ground also. Okay, so the 230 volts we have connected here, and if in a normal scenario, if you are connecting a bulb here, this bulb will be blowing up, and if you are actuating that, this bulb goes off and this bulb turns off. Okay, this is I might be like everyone might be knowing this, but still I need to give you a clear idea on this NC and NO, because I have to show how the PLC is programmed. So in that we are just talking about NO and NC, nothing else. So that's why I just showed you this. Now coming to the architecture part. So in the architecture, okay, so in here, we do have the PLC or the RPU. The DCS we'll be having the PLC or the RPU or a DCS and an HMI. Okay. Here it is an OR and here it is an AND. And everything will be concluding to a SCADA system, and again we will be having an HMI system. Okay. So what is this double HMI? So we'll be starting with the PLC and RPU. So PLC, consider that we'll be having 2 units. Okay, I will take this image for the reference. So we are having plant PLC 1, plant PLC 2. Okay, one plant, second plant. And inside the first plant, we have multiple devices. We'll be having like sensors, push button, temperature controllers. What all are there? IR sensors, what all sensors you know? Consider all devices which is connected to this particular PLC. And same as that, in the second PLC also, it is all connected to this particular PLC. And here you can see it's a remote PLC. Obviously, that will be a RPU system. And here we are having modem. So I think this is an old image. Nowadays, we don't use modem. Instead of that, we use switches. Okay. So every single, this remote PLC is now connected to a single switch, or in that image, it's a modem. So why we are considering a switch actually? So this image has a continuity. That means there is large number of remote PLCs. Consider that this is a what you can say, an electrical supplying service system, and we are having large number of substations along the complete destination or complete area. So there will be large number of remote PLC, or there will be large number of like what you can say, large number of RPUs. So all these RPUs will be coming together and connected to a particular switch. And that too inside, this will be an apartment type of substation. So that will be an indoor substation, and that is connected to this particular network. So this is the communication part. This is where we communicate. This is where the complete system is actually communicating with each other. Like the plant, this PLC will be communicating to here, and this will be communicating to here. Something like if the transformer is compromised, it will be communicating that, yeah, this remote PLC 1, the transformer has switched off. So there will be a huge surge that will be coming to this second plant PLC. So that will be communicating with each other. Okay. So either you guys have heard about the LAN system, WAN system, HAN system, like the wide area network, the local area network, the home area network, and DAN also, the domestic area network. So many area networks are there actually. Okay. So what is this hand WAN system? It's like, I'll just show you like, okay. So everyone, some of you guys might be knowing about the ping status. Okay. So what does this ping means? Like we are just asking the server or we are talking with the server. Okay. So anything related. So recently we had the blackout of WhatsApp or the blackout of this Facebook server. So actually, how we just get to know about, how network engineers get to know about that, we'll be talking with the server, what is actually happening. Okay. So we'll be continuously speaking with the network. So if I am turning off this, obviously this will be turning off also. So that is how, like, this kind of data will be sending each other every time, every single millisecond. As you can see, every millisecond, every PLC will be communicating to each other actually. So that is the importance of this network. Okay, so this PLC will be communicating to this and that to this. So when I showed you the google.com, instead of google.com, it came as an IP address. Okay, so each of these devices will be specified with an IP address. Okay, so this will be like 192.168.0.3. This is 0.2, 0.1. So 0.2 is asking 0.3. Everything is okay. No, my transformer is not working. So there will be a circuit tag. You have to take care of it. So 0.2 will be telling to 0.1 that yeah, this happened. So we have to take care. Okay. So this connection is lost. Sometimes this PLC is the feeder of this or the master of this. So once this electricity is provided here, then only these two will be getting. These two will be getting the power supply. So if it is compromised, obviously they have to take the backup. So they will be communicating with the generators or anything. Either it will be communicating with the devices, any of these devices. Either any of these devices will be a backup generator. So that is the importance of local area network. So from here, we are able to conclude about the PLC and the RPS. And I told like PLC or PLC RPS or DCS. So here we are using multiple number of PLC systems. Instead of that, every single PLC can be concluded inside a DC system. So only I told that this image is a kind of like an old version maybe. Okay. So instead of this PLC, all this has to be connected to a DC system, and that this DC system will be connected to the local area network. So, and again, we'll be having an HMI. So HMI is a common thing. Whenever you used to see a machine, we'll be having a screen over there. That is what is human machine interface, HMI system. So in a PLC system also, we'll be able to program the HMI. So we'll be getting to know, oh, this station is being down. So we can just control the particular PLC through an HMI. If an HMI is here, we are able to control this PLC. If an HMI is here, we can control this PLC, but we can't control this PLC. We can get to know about the status of this PLC. Okay. In an HMI, if an HMI is here, we are just able to know the status of other PLC, and we are able to control the particular or the parent PLC through a HMI system. And next is the SCADA. SCADA is the supervisory control and the data acquisition system. Okay, the complete heart of the system, not the brain. The brain is the PLC and the heart is the SCADA. So SCADA is like everything he is getting, every single details, every single information from every PLC, RTU, DCS, anything through the network. Okay, through this network he is able to get that. So this SCADA workstation will be somewhere in some other place. The remote location might be. Okay. So he is able to, so right now we are able to see that the SCADA system is connected to this local area network. So we can consider that this is a wired network. We are also able to consider this as a wireless network as well. Okay. So this will be connected to a tower and through a cellular data or through a Wi-Fi system or anything wireless. We are able to anything which is having a powerful communication database. We are able to consider that it as a wireless system. So the SCADA is like we are able to control, we are able to supervise, we are able to collect data, report data, that to real-time data. Okay, and also we are able to store that in a particular database. Okay, anytime, anywhere. And database means it can either be in a hardware or as well as in a cloud-based system. Okay, so that is what a SCADA system is. And the second HMI that I mentioned here, either it can be an operator workstation or nowadays we can consider that as a mobile phone. So consider that the chief engineer is having a mobile phone and he's having an application, and in this application he is getting to know that this remote PLC is down, this RTU, this particular RTU or the 0.3 is down. So the 0.2 and 0.1 has to be taken into consideration. So this chief engineer will be asking his field service engineers to work on that. So they will be coming with the laptop, and again they will be connecting to the switches here. Okay, they will be connecting this their laptop or any kind of system that will be connected to this particular network through the switches, or it will be either connected to a wireless router or a wireless modem or Wi-Fi system. So they are able to, if they are having the laptop, they will be connecting to this system using wireless, and they will be seeing that, oh, this 0.3 is down because of the transformer issue. Okay, and that was like 3 years back. Okay, 3 or 5 years back, they are able to do this. Nowadays, we are able to know that which part of the transformer is having what kind of issue. Okay, that much is the development that is being seen in control system. And the next upgrade part is this remote PLC, plant PLC, everything is now being changed to cloud edging system. Okay, like we'll be having a hardware system actually, but instead of that, everything is controlled by the cloud system. Okay, so that is the transformation that is being happening nowadays in the control system. So maybe like after 5 to 7 years, there might not be a situation like there will be PLC, there will be DCS, there will be RTS. Obviously, there should be a hardware system, but the controlling part will be virtually or like we will not be able to see that. Maybe just connecting the sensors, everything will be controlled from some other places by someone or something else. Okay, so that is what the architecture part of the control system. And next is like the control system. We are when we program a PLC. Okay, consider again the Arduino and the Raspberry Pi. We have the digital values and the analog values. So,
sir, excuse me.
Yeah.
Sir, there is only 10 minutes to end this session.
Sorry.
Sir, we need to end the session within 15 minutes. Just
okay, that's possible. Yeah. So we are having the analog and the digital system. So the digital system, we will know that we are using the Boolean values, so like 0 or the 1, like a switch, and the analog values will be like 0, 1, 2, 3, and it will be like along to the way. So that is what the difference between an analog system and the digital value. So, and finally coming to the programming part. So we are having like 5 different types of programming languages for PLC. The first and foremost common one is the ladder diagram, okay, which is the common or which is the beginning stage of a PLC program. And coming to the sequential function chart and the function blocks, it's like similar to the flow chart. The structured text is something similar to the hardcore programming that we used to see, like the commonly used is the C programming. Either it can be the C, C++, C#, anything. Okay, that is the structured text. And the next is the instruction list. Instruction list is like the sensors will be having a particular instruction, and that will be connecting to each other like a flow chart. So these are the 5 different types of programming languages in a PLC system. And coming to the conclusion part, it's my experience as well as giving you a guidance on the career path. So exactly like once upon my graduation, I went for just another course for taking an industrial automation system, and after that only I joined this YouTube communication system, which is the channel partner of ABB. And again, I thought that because I observed that when the global pandemic came, every single specific task that was done that time was tremendously switching to automation part. And since that is seeing the trend, we should be focusing on the automation in the since I'm an electrical engineer, I should be focusing on the hardware part as well. So I moved on to the hardware automation system. But later on, I realized that with the hand on the hardware, we will not be able to like pursue, or we will not be having a accreditation to our own area. So gradually I understood I should be having a little bit idea on the IT automation. Also, I should be having something on the networking. So right now I'm working in a company where our team is like 25 people in India. Okay, we just have 25 engineers in India. If anything happens abroad, we 25 have to go. So each of these engineers, there are mechanical engineers, civil engineers, electrical, electronics. Everyone is there in order to design the infrastructure, in order to design the robots, in order to program. Everyone has to know about the every single thing. Like the mechanical person should know about the networking and the computer part. The electrical person should know about the electronics and the signaling part. Every person should know everything related to that particular topic. So that is what the conclusion is. And I thought of showing you like the PLC programming. I think I don't have much time for that. So I think we'll be having sometimes we'll be having a collaboration with other folks to show you that. So that's all from my side. And if you have any questions, just shoot it. Thank you.
Thank you so much, sir. It was really an informative session. Thank you. Now it's the time for our doubt clearing session. So everyone may ask their doubts or type in the chat box.